The next system is a package. You see, package, like you see, dictable split, what we consider as a bigger version of split. No? Similarly, this package you can consider as a bigger version of window. Just for comparing, just for learning point of view, window is a very small unit, but package is beyond having the capacity beyond the capacity of window. Window, you can find this 0.5, so to say 2 TR. But if you talk about the package, start with the 3 TR, commonly available up to 125 TR, and it can be available up to 360 TR, depend on the location and the make. If you talk about, say, in Saudi Zamil, you can find up to 360 TR. But most of the manufacturers, they're offering this package in between, means starting from 3 TR up to 125 TR. And this range may vary from make to make and from location to location. So what I'm trying to explain is, if you're comparing this with a window, just I'm comparing as per the technology, not as per the capacity. Capacity point of view, it's a very big unit. Package, why I'm calling as a bigger version of window, because in window all the components, all the the major components you'll find in one unit. Na? Similarly in package also, all these four components in one unit. In that sense, you can compare, but rest of the thing is different. So let me give you the idea first, the concept. In the image, you'll get some idea. And at present on screen, this is called air cooled package. You will find water cooled package also in Blue Star or in few makes, not commonly used. In India, you'll find this water cooled package in Blue Star or in few locations, but most commonly in Gulf or in many locations, package is commonly available as air cooled. And the difference between air cooled and water cooled system. At the time, at the time of vapor compression cycle, we discussed this point. If the condenser is cooled by air, that this system can be a package or can be a chill water system. That we'll discuss next. Next means after completing the VRF and other systems. So if condenser is cooled by air, that system we can call air cooled system. So here in package, you see, first of all, the components: compressor, condenser. This we can consider as one section. The second section, you'll find evaporator and this fan motor and a blower. And you'll find the expansion also. Expansion, you'll find it can be in section 1 or section 2, because we are not bothered about the noise now, because this complete unit is placing outside the building. In case of split, this expansion you'll find in outdoor to reduce the hissing noise in the indoor. But in this case, depending on the model, it can be on this side or this side. So these four components in one with the two separate section. And remember this section 2 with the double skin. And double skin term you'll find in the specification. Double skin refers to insulation body with the insulation, means here you'll find the insulation. And why insulation is required? Because you'll find the cooling effect on the evaporative coil. No? On this side, we don't require insulation because we are interested to reject the heat. You'll find the fan on the top, so the air will suck from outside and through. So we are interested to reject the heat. But this side insulation is required to avoid the loss of the energy, means loss of cooling. Okay, so in package at evaporator side, you'll find double skin, nothing but a cabinet, then insulation, again inside one more cabinet. Okay, and here in this image, you can find, you see,
Double skin means in the both the
double
side.
skin means insulated body with the insulation.
Okay.
Okay, you'll find a cabinet, then insulation, then one more cabinet inside, or a cabinet with insulation. Inside, you'll find a thermocol or a polyurethane completely in the site. So generally, we used to call double skin. So remember the term double skin means body with the insulation. Okay, it can be with the different units also. So on the right side image, since it's air cooled, you see this fan is used to cool the what? Condenser, this side. Okay, so this side is a condenser side, high side, and this side is a low side. In that you'll find the evaporative coil and a fan. And this is, we can call as a supply duct, and this we can call as a return duct. And how you can identify this? Remember, supply duct compared to the return duct is smaller in size. Why? We'll discuss that the type of duct sizing. Just for identification, this size is bigger than this now, or else any at this level, ignore this. You can consider one as supply, one as return. This is used to supply the air to the conditioned space, and this is return from the conditioned space. And in between, we can provide the fresh air also. Okay, so the first point, this is a bigger version of window. Second point, we can attach the duct. I'm talking about air-cooled system. Water-cooled we'll discuss next. Let me complete the air-cooled. You see, second point, we can attach the duct. In that, we required a supply duct as well as a return duct. In the previous case, return duct was optional. Let me show you. You see, in this case, there is no return duct. This is called free return because in all the cases, we don't require the return duct. So what will happen in this case? This complete area above the false ceiling, we used to call return air plenum. And this is called free return. Anyhow, this suction is above the false ceiling. But if I place this complete unit outside, means return is required from the space where you are supplying. Okay, so for air cooled package, remember return air duct is required. If you not use the return duct, what will happen? The suction of the complete outside air, and outside air is hot and humid in summer. So that will directly increase the load on the cooling coil. And the fresh air is hot and humid. And if you completely use the fresh air without return air, what will happen? The load on the cooling coil is going to be more than double, because remember the heat gain through ventilation also one of the major source of heat gain in summer, in winter also for heating system, but at this level I'm talking about the cooling system. So return is required. How exactly? I'll show you the drawing also. But you see, just this duct is entering, say vertical duct, then again it will enter in the floor. In the floor, it will connect to the A terminals like a previous ductable split. And above the false ceiling, you'll find the return duct, and the air is this. With the return duct, we can use this. And you see, we can add a opening here with a damper to introduce what? The fresh air. I'll show you in the drawing the detail about this. So we can provide the fresh air also as per the requirement. We can provide the duct for uniform distribution of air. We can provide the fresh air and the capacity. We can use this for complete floor, for multiple spaces, or for a complete villa, or for a complete building. Building means like G+3, G+4, etc. Depend on, and I'm not talking about high-rise building. Okay, so this is simple concept for what? Air-cooled package. We have some more points to discuss. You see what I explained? It can be considered as a bigger version of window, and the capacity beyond the capacity, and we can attach the duct with the ventilation. Typical available in starting from 3 tier up to 125 tier, and in market you'll find 360 or 400, more than that, depends on the make and model. In general, for entry point of view, you can use this option. Now, if you talk about the types of package, what I explained just now is air cooled. Why air cooled? Because this condensing unit is cooled by air. But next we have a water cool also. But let me complete this air cool first. You see, this is a detail for air cool. The same components. You see, this is for supply duct, which can supply to a complete floor or can be a multiple floors. And this is a return from the space. In the drawing, I'll show you one more image. If you have confusion, you'll get the clear idea. Apart from this, you'll find all these components, what I explained: compressor, condenser, expansion, evaporator, everything in one unit. For entry point of view, this is air cooled because this condenser unit is cooled by air. That's it. This is a major difference between air cooled and water cooled package. Okay, so I'll explain water cooled. Let me complete this air cooled. Here I'm showing one. Let me show you one drawing. I add one image also to understand the concept. You see, here in this is air cooled package. You can consider this as a supply duct, and this is return. You see, supplying the air to this, say, first floor, supplying the air to the ground. At the back side, this duct is continuing, and it is supplying the air even to this ground floor. And you see return from the ground floor is here. Like supply, we don't require complete return duct. One opening is enough because you see this complete air is going to suck, or else we can go for one more opening here. And all this we can collect with the bell mouth opening. I'll show you bell mouth opening in the drawing. Then you see this complete return from ground floor, return from this first floor and supplying back to the unit. In between, we can introduce the fresh air as per the requirement, as per the calculation. How much opening is required for fresh air that you need to calculate, and that much opening you can add here at the return with the VCD. The same you'll find in the drawing. Now try to understand this in the drawing. You see, here is a small villa of G+1, and you see on the roof, one package is installed. RTPU, rooftop package unit, F1, and here F1 is, this is for first floor, and you see this is supplying the air to the ground floor. Okay, so we'll verify for one, say first floor. This package you can find, you see, this magenta color is a supply duct, and this yellow color is a return duct. Okay, and how I can say it's a supply, most standard point of view, this cross means supply, one diagonal line means return. You'll find all this at the time of ducting, just I'm giving the preview. So you see the duct, this is placed on the roof now, and this duct is running, and here this is a shaft, means a building, this OTS or a shaft means vertical. And this duct you can find, it will enter in the first floor. This left side is a first floor. You can find, you see, in the first floor, this duct is entering in the first floor after the vertical duct and supplying the air to the complete first floor. And if you talk about return, you see, return is only a piece of duct. This is called bell mouth. We are not running the return like supply na, because above the false ceiling complete area we can consider as a single zone. And this is a return duct, and this return duct again to this floor. And now you can find opening FAD, fresh air duct, you see, with the VCD. So we'll go for we are connecting the fresh air duct with the VCD like a valve. So normally it's open so that the fresh air is introduced with the return air. So fresh air and return air mix and supply back to the rooftop package unit at the evaporative side only. The condenser side is totally separate from this ducts. It will not connect to that because condenser means is used to suck the air from outside and throw outside only to and picking the heat from the condenser. This two duct, it will connect at the evaporative side. One is supply, one is return. Just try to understand the concept of package. About this terms and terminology used in the duct, we'll discuss later. We have a separate topic for this. So got the idea online about the package, air-cooled package. So why we are calling air-cooled? Because, you know, the condensing unit. Now we'll talk about water-cooled package. You see, in water-cooled package, this side is 100% same. Means this air side, this supply duct, this side is 100% same in water-cooled package. You'll find change in the condensing side. So in water-cooled package, the condensing unit is cooled by water. Okay, so just we'll discuss the difference. Rest of the thing is same. Okay, so you see in water-cooled package, here we'll connect the supply duct, return duct. This side is same, and this unit is placed inside the building. The air-cooled package must be placed outside the building because the condenser is air-cooled condenser. No? Achha, one more point. Remember, when we connect this duct, this supply duct or return duct, since this is partly inside and partly outside, na? So this duct which is outside the building, you must cover with the insulation. Even inside the building also above the false ceiling, we are using the insulation. But in some project, you will not find the insulation inside the building. But as per standard, complete duct, supply and return with insulation. If you not use the insulation, you know, the cooling is going to lose na, in supply duct. Okay. And in return duct, it may gain the heat from outside. So unnecessary, the load on the coil will increase. Okay, and the same thing is applicable even for water cooled package also. So as I said, na, air cooled or water cooled package, the air side system is same. Next, so let me continue with the water cooled package. So in water cooled package, the condensing side is different, and the condensing unit is cooled by water by using a shell and tube condenser and will cool the refrigerant which is flowing in shell and tube condenser by using water. And that water we are going to cool by using a cooling tower. Okay, so try to understand only the condensing side circuit. Rest of the thing is same. So you see, this side is same as air cooled. But you see, this condenser type is different. In the previous air cooled, you will find the coil and fin type. Air cooled, that is that fan and tube condenser. But in water cooled, you will find shell and tube type condenser. And remember, shell and tube type can be a condenser or can be a evaporator. And that concept you'll find in chill water system. So shell and tube is a heat exchanger. Can you find different type of heat exchanger? You see, this also heat exchanger. This evaporative coil. This also heat exchanger. Na? This is a what tube and fins type. You'll find different types of heat exchanger. Can be used to reject the heat or extract the heat. Depend. Similarly, this is shell and tube heat exchanger. In water cool package, we are using this heat exchanger for condensing site. So we used to call this as shell and tube condenser. Okay, so try to understand the concept for this condenser side. Very simple. You see here the detailed view for this. When you see this pipe, if you talk about this line diagram, this pipe I can connect and this pipe I can connect here. I'll show you, but let me complete this shell and tube condenser first. Shell and tube. You see the outer one is called shell. Inside you'll find the tubes. So we used to call shell and tube. And here the water in and this say water out. H2O out and this is H2O in. And you see when the water in the shell, inside the shell you'll find the tubes. And inside the tube, you see you'll find the covering like this, refrigerant in. And here you'll find, say I'm using a pipe, say refrigerant out. So when the refrigerant in, it will flow inside the tube, not enter the in the shell, in the tube. So refrigerant in as what? Since it's a condenser, refrigerant in the hot state na, after compression. Now, when the refrigerant in hot state, we are supplying the water, not chilled water, normal atmospheric temperature water or a cold water, I can say. So when the cold water enter in the shell, it will flow what over the coils, and you can find the partition. This is called baffles. So water in and it will flow like this, and water out. And water is responsible to extract the heat of refrigerant. Extracting the heat from the refrigerant, you know, condensation happen. And at the outlet of this refrigerant in the liquid state, you know the process. Here we are cooling the refrigerant by using the water instead of air. What we discussed in vapor compressed cycle. If you use the air to cool the condenser, that is called air cooled system. If you use the water to cool the condenser, that system we can call as a water cooled system. So here we are talking about package. So this is water cooled package. So we are using the water to cool the refrigerant. But again, in order to use this water again, the water must reject the heat na, because it's a cycle, right? So what will happen? This hot water, which is from the shell, we are supplying, you see, here cold water in, hot water out. You see this out, I can write here. And this in, I can write here. So cold water in, and it will extract the heat from the refrigerant, hot water out. And this hot water we are supplying to cooling tower. In cooling tower, you will find forced convection. What will happen in the cooling tower? The hot water which is out from this condenser, we are supplying in the cooling tower in the form of a sprinkler. I'll show you this cooling tower. Let me complete this. So at this level, just remember, when the water is supplying to the cooling tower, here in cooling tower, we are using a fan and it will suck the air from this passage. And this water, the hot water in the cooling tower, we are supplying in a sprinkler form. So what will happen? The air, this is a forced convection because you'll find the fan. The air will extract the heat from the water, evaporative cooling. Only the cool water is allowed to condense, allowed to collect at the bottom. And the hot vapor, this cooling tower is throwing off. Nothing but a evaporative cooling. Like in air cooler, you'll find the evaporative cooling. Na? So the heat from the air, the heat from the water, which is used to cool the condenser, is going to extract by using this cooling tower. Only the cold water is allowed to collect at the bottom, and the same water is used to supply back to the shell and tube condenser by using this pump. And this pump you can call as a condenser pump. Very small capacity pump because it's a package. In case of chiller, water cooled chiller, the case will be different. You'll find higher capacity. And remember, the same concept for condenser you'll find in water cooled chiller also. This will help you at the time of when we deal with the water cooled chiller. And in air cooled chiller, you'll find shell and tube evaporator. So shell and tube heat exchanger you'll find in air cooled chiller as well as in water cooled chiller for condensing side as well as for evaporative side. So this concept will help you. At this level, just I'm giving the reference. So since in this system, the condenser is used water to cool the refrigerant. So this system we can call as a water cooled system, and this system is a package. So it's a water cooled package. And remember, this unit we can place inside the building, but this cooling tower we cannot place inside the building because this is used to separate the hot vapor from the water. So this must be placed outside the building only. Got the idea online? You see, at this level, just remember, cooling tower is used to cool the water. How exactly in detail I'll show you at the time of water cooled chiller. Just I'm holding this because again the same thing will repeat.
The cycle in between the condenser and the cooling tower will be remaining same as like in the water cooled chiller, right?
Water cooled chiller.
Yes, yes, yes. The cycle in between condensing unit and the
yes, yes.
cooling tower is same as the
See,
water
if
cooled
you talk
chiller.
about water cooled package or water cooled chiller, the condensing side concept is same.
Condensing and the cooling tower cycle is same.
Yes, I'll show you with more details because this here is a package. So I'm just explain the concept. At the time of chiller, we'll discuss with more detail because you'll find the separate cycle. Anyhow, the concept is going to be same, but I'll show you with more detail. At this level, I've not added much details in this because you see in actual practice, in Blue Star or Mitsubishi, with few makes only you'll find water cooled package. So this is not commonly in Gulf or in Western countries. You'll find in India with that with the Blue Star or with the Mitsubishi. I think Blue Star is confirmed. So this is not commonly in market. So that's the reason I have not given the detail at this level. But don't worry, when after completing water cooled chiller, you'll get clear idea about the cooling tower. Only I'm holding this.
Any advantage or disadvantage of both the system? Like
Yes, you'll find in the next page only. So any confusion in the concept of air cooled and water cooled system online? What air cooled and water cooled package? Got the concept now?
yes, yes.
Yes, sir.
Now you see, if you want, you can make a note of this point. A refrigerant.
Just 1 minute. Please continue.
First point you can write. A refrigerant is 20 times more effective than, in extracting the heat.
Refrigerant is 20 times more
effective in extracting the heat than air. First point means if you use refrigerant to extract the heat compared to air, it offers 20 times more effectiveness. Second point, refrigerant is 10 times more effective in extracting the heat than water. One more point, water is 10 times more effective in extracting the heat than air. Now you can able to compare this air cooled and water cooled system, and the same point is applicable even for air cooled and water cooled chiller also. So remember, if you see this air cooled system is effective, don't write this, let's listen. I'll give you this point at the time of air cooled and water cooled chiller. At this level, just listen. You see, if I use air cooled condenser will provide you the best efficiency if the outside temperature below 35 degrees centigrade. If the outside temperature above 35 degrees centigrade, like 45 or 50, like in Gulf, in that case, water cooled efficiency or water cooled system efficiency is higher, because if the outside temperature is higher, if you use the air to cool the condenser, the difference of the temperature is less, na? So the efficiency of that air cooled system drops. In that case, water cooled system work efficiently with a small size capacity system. Means I'm talking about the size of the system. You can expect the higher efficiency even in air cooled, but the size of that air cooled condenser will increase. So if you want higher efficiency with compact in size, you can expect in water cooled system. This is the main point. Apart from this, we have some more points to discuss. Next, you see, We have advantages of this package and disadvantage also. Ventilation as per standard. You see, this advantage is common for air cooled and water cooled both. You can provide the ventilation in both the side because you see air side system is same na in air cooled and as well as in water cooled. Next, easily available in I'm talking about air cooled. Air cooled is easily available in all in many locations. Water cooled is limited. But if you talk about, you see, generally package means generally the people are thinking for air cooled package only. Water cooled, as I said, na, just available with the few makes only, not in all, or not in all the locations also. So easily available. I'm talking about this air cooled side. Next, it's a factory assemble, so you can expect the quality. On site, we need to go for the ducting, installation of ducting side, but the refrigerant piping and all, we are not disturbing anything except this. Again, this point is related to the air cooled. In water cooled side, again, the cooling tower side, we need to go for installation. But still, in that case, also, we are not disturbing the refrigerant cycle, and it can be placed on the rooftop or any open space away from the building or backyard. Rooftop means, again, I'm talking about air cooled package. We are not placing the water cooled package on the rooftop. Water cooled package we are placing inside the building, except the cooling tower. So just most of the points is related to air cooled because commonly in market you'll find air cooled package, and it will not affect to the building elevation because we are not placing on the wall on the like split system. We are placing on the dedicated area on the roof or a separate space backside of the building. And in case of maintenance, the technician can work easily because it is not on the wall hang, and it ducts have acoustic lining to reduce the noise. Acoustic lining means inside the duct. You see this hatching double hatch represent lining, acoustic lining. It can be a nitrile rubber or it can be this fiberglass. We have a separate topic of duct insulation. Under that you'll find thermal insulation, acoustic lining, and you see double hatching represent internal lining which is used to reduce the noise. Not only for package, even for other systems for duct we require this insulation to reduce the noise. That is called acoustic lining. Because the fan motor is the higher capacity, na? Because the fan motor is used to supply the air to the last air terminal. Okay. Next, if you talk about disadvantage, you see capacity of fan should be higher because we are placing the unit away from the conditioned space. From that point, we are interested to supply the air to the last air terminal. Okay, so the fan capacity comparing with the ductable split. In ductable split, outdoor is outside and the duct is going to start from the AHU, and AHU we can place inside the building. So the length of the duct means starting from inside the building only. So, and if the length of the duct decreases means the fan capacity, the static pressure which is used to supply the air also decreases, means the HP of the fan motor will decrease. But in case of package, since we are placing away from the conditioned space, or if you talk about air cooled package, we are placing on the outside the building. From that point to supply the air to the air terminal, so we require higher capacity, and that will increase the air side running cost. Next, as I said, the duct must be completely with insulation to reduce to avoid the energy losses. And the initial cost. The initial cost is high compared with what split system. I'm not compared with the chillers. Chillers different category. If you talk about split system, the cost is almost 8 to 10 times higher. Okay, not sorry, my mistake. Five. This you can consider say 4 to 5 times higher. In VRF, the case is different. You can approximately consider 4 to 5 times higher because first of all, the unit is expensive and the
As
installation
compared
cost
to
also increases compared to split. The installation cost also increases and we require separate ducting installation, ducting fabrication. So compared to split system, we can expect minimum 4 to 5 times expensive. We have some more system to discuss to deal or to complete this chapter 5. So the next system is VRF or VRV. We'll discuss in detail. Apart from this, in this chapter, you will find geothermal system, district cooling, and the very, very important chill water system. So let me proceed with the VRF. You see, in short, we used to call VRF or VRV. It's a variable refrigerant flow or variable refrigerant volume. And this comes under DX system. DX nothing but direct expansion. What exactly DX? I'll give you the idea after this topic. At this level, remember DX system means the refrigerant is responsible to cool the air compared with the chill water system. So VRF also comes under DX system. And in VRF, if you compare this VRF with the split system, the major difference is, this in a split AC or inductable split, you can connect one indoor to one outdoor. But in case of VRF or VRV, we have option to connect multiple indoors to one outdoor. You can find on screen also on the left side image. You see, consider this as one outdoor, one unit, and to which we can connect different types, multiple indoor, nothing but FCU or AHU. You see, these are all FCUs. And below we can call this is AHU, this is concealed AHU, and this is a cassette. So first point is, with one outdoor, we can connect to multiple indoors. And the second point is, the indoor can be of different types, which suits the interior requirement or the site condition. So we have a lot of flexibility in this. As per the interior requirement, if they ask for cassette or high wall or freestand or concealed FCU or a ducted AHU, we can use any of this type. Now, so we'll discuss more about this. This is interesting and important. And in present market, this is becoming popular in India, in Gulf, or in many regions, because we have a different types also in this. So what are the different types and how the system works and how we can save the energy in this compared with the normal split system? All these points we'll discuss in this session. So you see, VRF in short is a variable refrigerant flow, or VRV, variable refrigerant volume, are both HVAC technology used in commercial and residential building for efficient temperature control. And don't get confused, technology point of view, VRF and VRV both are same. Then why we are using the different name? You'll get the answer for this. The VRF name is patented by Daikin. And this technology is originally from Daikin, from Japan. And they introduced this in, I think, 1982. Okay. And they have given the name as VRF. So that's the reason they have a patent for this name. So other manufacturer cannot use this. So that's the reason other manufacturers, they're using this term as VRF. So technology point of view, both are same. Make to make, you'll find some difference, some additional options, additional features, etc. But concept point of view, VRF or VRV, both are same. Don't get confused. So what I explained the same, one outdoor can connect to multiple indoors of different types with the different capacities, and how it can be done, how the system works. We'll discuss in detail. Let me complete some theory first. So here you see, next some important points before moving to the different types of VRF. In VRF also you'll find the different 3 types. We'll discuss in detail. Some important points you can find on the screen. As I explained just now, VRV is patented by Daikin. So other manufacturer, they can use the term as VRF. Okay, technology point of view, both are same. And you see, one outdoor can connect to more than 60 indoors of different types of FCU or AHU. Okay, FCU can be concealed FCU, it can be a decorative FCU, or it can be floor mounted AHU, or it can be a ceiling suspended AHU. So don't worry, at this level, we have not discussed in detail about FCU and AHU. We have a separate topic, but you see on screen, this is AHU. These are all AHU on the right 3, and above all is, including this cassette, is FCU. These are the different types of indoor unit. Okay, but we have some different based on the capacity and based on some features that we'll discuss. We have a separate topic before moving to the still water system. Next, you see 60 or more than that depend on the make and the location. Some manufacturers, they're offering up to 20, some are offering there up to 60 or up to 65, some makes, depend. And the numbers may increase as per the improving the technology. But in the market, most commonly, is available up to 60 indoors. Next type of compressor. This is important.
It depends on capacity or number of indoor units.
You see, capacity, we have in that capacity only, we need to match that one. Okay. And we have a capacity in general up to 40 or 42 TR. Okay. In that, you need to match the indoors. Don't worry, don't do the conclusion. But we have a possibility to connect to up to 60 indoors, but definitely as per the capacity of outdoor. If the outdoor capacity is 20 TR, so we cannot connect more than 20 indoor of 1 TR, right? So in that way. Next, you see type of compressor. This is also important in VRF. Not only in VRF, now in market, even in split system, or even in chill water system, you'll find this type of compressor. But mostly the inverter compressor or digital compressor start with the VRF system. Now it's available in the split system also. So you see type of compressor you use in VRF. When I use the term VRF means include that VRV also. Okay, repeatedly I'll not use both the terms. VRF means by default with the VRV. So the type of compressor, one is a digital scroll compressor and the second is a inverter scroll compressor. And as a mechanical, you know the different types of compressor, no? Screw compressor, scroll compressor, reciprocating compressor, etc. But remember in VRF, we are using scroll type. And even in split system with the inverter type, you'll find scroll. And now in many vendors, even in split, they are using the scroll because the noise point of view or efficiency point of view, you have advantages. So as a mechanical, I believe you know what is scroll compressor, right? Again in scroll, we have digital scroll. So digital scroll means it will engage or disengage like in four-wheeler we have a clutch. Now clutch is used to engage and disengage the engine from the transmission. Similarly in digital scroll compressor, just I'm giving the idea. If you want more, you can just watch the video after the session, because for everything I cannot go in the detail. I mean, that is not required also. So digital compressor concept is it uses engage and disengage concept as per the load requirement. Okay, but the type is scroll only. An inverter scroll compressor, you'll find this variation in speed. The inverter scroll compressor can run with the different speed because this work with the VFD drive. Okay, so what is VFD? You'll find in the next only, and very important concept, not only for compressor. VFD concept is important for the pump as well as for the fan also in the HVAC. So I'll try to give the idea of the VFD, this VFD, variable frequency drives. So inverter scroll compressor is a scroll compressor, but it can run with the different speed as per the load demand. If the load reduces, the RPM of the scroll compressor decreases. If the load increases, the RPM of that scroll compressor increases, because this is connect with the VFD drive. So how exactly VFD? You'll find in the next only. Next, you see the type of refrigerant commonly used in VRF system. May ask in interview. 410A or 407C, R32 or R454B, and all belongs to HFC category, hydrofluorocarbon. You know what is HFC. Next, this is also important point to discuss. You know this in a split system, the maximum length of the pipe in between indoor to outdoor, we discussed now 25 to 30 feet, or some manufacturer as per the capacity, it may up to 15 meters. 15 meters nearly 45 feet. And that depend on capacity, because if you talk about the split cassette type with 4TR, because splits available up to 4TR, no? With the 4TR, the length of the pipe also, you may get up to 45 feet, nothing but 15 meters. So the limit for the split is what? 15 meters. That too as per the capacity, not for all. For 1.5 to 2.5 TR, you may get 25 to 30, not more than that. But in case of this VRF system, you see the limit is up to 150 meters. But in this also we have points to discuss. 150 meter on what case? If the outdoor and all the indoors which is connected at the same level, means suppose the building is of only ground floor and the outdoor unit is on the roof, means that this is almost with the same level, the outdoor unit and the indoor units with the same level. So we can go up to 150 meters. This is in general. Again, this may vary from make to make. This is most manufacturers, they are offering this. This is the first point. Second point, if the outdoor unit is, you see, above and the indoor unit is below, suppose the outdoor unit is on the roof and the indoor unit is connected to multiple floors, say 5-floor building or 7-floor building, in that case the limit is 50 meters. And if it is reverse, for example, this is outdoor and this is indoor, the indoor is above, the suppose outdoor is placed on the ground level and it's connected to multiple indoor on different floors, you see outdoor unit below indoor, in that case we have 40 meters. Okay, so this is in general for interview point of view. Again, you need to refer the manufacturer catalog at the time of pipe sizing, and we have a separate topic of pipe sizing for the VRF using the catalog from the vendor, or we have softwares also because this is a precise or precision type of machine compared with the other type. So this guideline, remember, may ask in interview. Next point, you see 30 to 40% power saving or energy saving compared with the normal compressor split system. Again, as I said, in a split system also you'll find this inverter type scroll compressor. In that case, you'll find very close power saving. But if you talk about the normal compressor split system, in that case, you can expect 30 to 40% saving of energy. Okay, and that's the reason now even from LG or from Carrier, from many brands, for in split system, they are offering inverter technology. And you know this power saving, 3-star or 5-star rating. And we are getting a very good power saving. So even a middle class family also can afford this because they can able to pay the running bills compared with the 5 years or 10 years back because of this technology. Next, you see inverter compressor RPM change as per the load demand, what we discuss. Why? Because it uses VFD drive, variable frequency compressor. So what is VFD? We'll discuss now. So remember, we have this term VFD and VSD. VFD is a variable frequency drive and VSD is a variable speed drive. And remember, by default, VFD is also VSD. Means if the pump, compressor, or a fan, remember this technology is for all means for compressor, for pump, or for fan. Pump means I'm talking about the chill water pump or condenser pump, we'll discuss. And fan you'll find in the AHU, you'll find in the FCU. In that also you'll find this technology, especially in the AHU for power saving. So remember, if you find this VFD technology, it means by default it's a VSD. So variable frequency means as the frequency, and frequency means I'm talking about the power frequency. Okay. And for in Indian market, the power frequency is 50 hertz, and in US it's around 60 hertz. So this frequency will change. So remember, variable frequency drive means I'm talking about the frequency of the power supply. So if you change the frequency of power supply to a pump or to a compressor or to a fan motor, at this level, take example of compressor. So what will happen? The RPM of that also change accordingly. And you can find the point here. You see power frequency is directly proportional to the compressor speed. In case of compressor, you can add pump or fan also. Okay, so as the power frequency changes, the speed of the compressor also changes. As the frequency increases, one minute. As the frequency increases, the power, this RPM of that compressor also increases. As the frequency decreases, it will also decrease. Okay, and this is VFD. I'll give you more points related with it. But first of all, you see, if the system is only VSD, it means it can change the speed without changing the power consumption. By changing the speed by using the gears or the pulleys, but the motor speed is going to be same. So the motor's speed is not changing. We are changing the fan motor speed RPM by changing the size of the pulley or suppose using the gears. In that case, the system is only VSD. There is no change in the power consumption. So remember, VFD means by default it's a VSD, and as the speed decreases, the power frequency means the power consumption also changes. It may increase or decrease. But if the system is only VSD, it means the speed can vary, but the power consumption will not vary. There will be no saving in energy. Take example of a ceiling fan. Ceiling fan I can run with a speed 1, 2, 3, 4, 5. Na? But that ceiling fan, we don't have the VFD drive connected. So the ceiling fan we can say is a VSD, variable speed drive, but not the variable frequency drive. The power consumption in all the speeds is going to be same. So remember, power frequency changes, then the speed of that compressor also will change. And the same concept applicable for pump and fan. And why I'm adding this pump and fan? Because this same VFD concept you'll find at the time of pump selection as well as for fan selection. Because in pump, if you talk about secondary pump, the secondary pump is a variable, this variable speed pumps. Okay, and even in VAV system, the fan motors are variable speed drives, nothing but with a VFD drive. Okay, so this concept is important. So you see, a variable frequency drive, VFD, is an electronic device used to control the speed and torque of an electronic motor. And this can be achieved by varying the frequency and voltage supplied to the motor. What you asked just now. VFD are commonly used in industrial and commercial appliances to improve the efficiency, energy efficiency, and now in market in HVAC, plumbing, not commonly in firefighting, because firefighting we are not talking about running cost. In plumbing also you'll find this concept for the pumps to save the energy. So how exactly? You see, actually this VFD concept is belongs to electrical side, but as a mechanical we are using in application side.
Yes.
At least you should have some basic idea. So I'll play one video. You'll get some more idea about this VFD.
So what exactly is a VFD? Well, it stands for variable frequency drive. They are used for running an AC motor at variable speeds, or let them ramp up their speed to give them a smooth startup.
You see, for example, at this level, we are talking about VRF now. So you can consider instead of motor, you can consider this as pump. Sorry, this is compressor.
Some people simply call them drives. They work by adjusting the frequency of the motor to adjust the RPMs. To do this, a VFD will actually convert the voltage twice. First, it converts our three-phase AC to DC. This is accomplished with diodes. Then it cleans the DC with a capacitor. Next, it will convert the DC to AC. This is accomplished with transistors acting as switches. Utilizing these switches is what allows the VFD to adjust the frequency that the VFD supplies to the motor. This in turn controls the speed of the motor. Now, I know this is a lot of information to take in. Let me compare the internal workings of the VFD with a simple plumbing system. First, let's look at the diodes that convert the AC to DC. This operates like a check valve in a water system. A check valve, like a diode with electricity, only allows water to flow in one direction. The capacitor acts as a water filter to keep everything clean and usable. The transistors act like valves. They turn the flow on and off when needed. This allows the VFD to adjust the frequency of the motor. Now that we have an understanding of how a VFD works, let's see what they're used for. One very common use in industry is to control the speed of a water pump in a water treatment facility. A water treatment plant typically has a constant flow of water coming into the plant. However, if the water demand exiting the plant is lower than the supply entering the plant, then the operator will need to slow down the supply. This is achieved by using a VFD on the AC motor. The operator can monitor water flow and manually adjust the VFD accordingly. Another great thing about VFDs is the fact that they can be controlled with a PLC. Using basic communication protocols that have been covered in previous videos, such as RS-232 and RS-485, PLCs can monitor and control motor speeds using the VFD. This helps make a process like water treatment that much easier and more efficient. This setup can be used in any situation that would benefit from automation. Let's look back at what we now know. VFD stands for Variable Frequency Drive. They are used for controlling the speed of an AC motor. They are also used for ramping up a motor for a smooth startup, or to prevent a heavy load from straining the motor on startup. This is accomplished by adjusting the frequency delivered to the motor. A setup of an AC to DC converter, then DC to AC converter. VFDs are used throughout industry. A common example is to regulate water flow entering a water treatment plant. VFDs allow the operator to control the flow of the pump manually or automatically with a PLC. There are many different brands and features available. If you're looking at using a VFD,
so I think you got the idea about this VFD. You see, if you go into the basics, it's a very lengthy calculation in the concept that is not required for a mechanical. So what we need only the concept. So how this frequency change with the power, with the current, with the voltage, we have a lot of relations between that. Okay, so if you want, you can just refer any book, but that much is not required for a mechanical. As a mechanical for this system, we are interested for the concept. Okay, so the concept is we are changing the frequency to reduce, to change the speed of compressor at this level to reduce or to to save the energy. That's it. But a lot of things are involved in this. So this part we are using in this VRF system. Let me proceed. Next, you see, these are the basic to learn the VRF system. Okay, what I explain. So the first point is what? One outdoor, multiple indoors, and the compressor is of scroll, inverter scroll, or it can be a digital scroll. Digital scroll, not in all the make. Most commonly you'll find inverter scroll compressor. In some makes you'll find the digital type also. Digital concept is just engaging and disengaging the compressor with the load, like clutch we are using in the transmission in the four-wheeler. So this is also one type, but commonly you'll find inverter scroll compressor that works with the VFD.